Okay, in our last class we discussed about the carbohydrates definition. Then we came to know about the classification based on the hydrolysis of the saccharide units as monosaccharides, oligosaccharides, then we see polysaccharides. Now today we'll see the structure for glucose. The structure for glucose, how glucose structure has derived, we can say. Okay, glucose, as we know, it is known as aldohexose. Last time we discussed hexose because we have got 6 carbon atom, and since it is aldehyde, aldohexose. Okay, it is also known as dextrose. Okay, now this glucose is, we can say that it is the monomer of many larger carbohydrates or sucrose. Okay, so first point is molecular formula that we know is C6H12O6. Now how to prove, how we are determining the structure for glucose. The first step is that when you hit this glucose molecule, this glucose is written in short form. Okay, CHO, then that 4 carbon atom written together, 4 and CS2OH. So when you treat with HI, hydrogen iodide, it will give you a straight chain N-hexane, that means with the 6 carbon atom. So from this it suggests that all the 6 carbon atom in glucose are in a straight chain because we are getting N-hexane. Okay, similarly, next point is that when you treat glucose with hydroxylamine, that is derivative of ammonia, NH2OH, you'll get oxime. You'll get a oxime, and if you react with hydrogen cyanide, you get cyanohydrin. So if you get these two kind of products, then we can say that in glucose there is a presence of a carbonyl group. There is a presence of carbonyl group, that is aldehyde. The next thing that we need to know is, say for example, fourth point is glucose when get oxidized or when react with the oxidizing agent like bromine water, it will give you gluconic acid. That means the aldehyde will convert into a acid group since it is an oxidizing agent. Okay, bromine water. It means that in glucose molecule, the carbonyl group that is present is aldehyde, because after oxidation it is giving acid with the same number of carbon atom. Next is, in glucose, if you see the structure, we have got 5 OH group. Now how to prove that there are only 5 OH group? Okay, so for that, this glucose molecule is treated with acetic anhydride. When you treat with acetic anhydride, if you get glucose pentaacetate, that means if all the OH will be substituted by the ester group, if forms ester group, then we can say that if there is a formation of glucose pentaacid, then we can say that in the glucose molecule we have got 5 OH group, because there is a formation of 5 ester group, because OH, alcohol, and acetic anhydride act as a acid. So when an alcohol reacts with acid, an ester is produced, that we have seen in our previous classes. Okay, so the reaction of glucose with acetic anhydride proves the presence of 5 OH group. Now next is, when you oxidize this with nitric acid, gluconic acid is formed. Okay, gluconic acid is formed, and this gluconic acid on further oxidation will give you saccharic acid. This indicates the presence of primary alcohol OH in a glucose molecule. So in glucose molecule, we know that we have got 4 secondary alcohol and 1 primary alcohol. How to prove that there is 1 primary alcohol? So for that, what you have done is, the glucose is treated with oxidation, is treated with nitric acid, it forms gluconic acid. That means nitric acid is an oxidizing agent. It will oxidize aldehyde group to acid and primary alcohol, first to aldehyde then acid. Okay, so this confirms the presence of 1 primary alcohol. So by all this experiment we came to know that with HI reaction we came to know that all the 6 carbon atom in a straight chain. With the second one we came to know that we came to know that we have got um, carbonyl group, and with carbonyl group we prove it at aldehyde. And after that we also prove the presence of 5 OH group in the molecule. Okay, and after that we have proved that there is one primary alcohol. Okay, this we call it the structure determination of glucose.